Welcome to the Introduction to Quantitative Geology course. My name is Dave, and I am the instructor for the course. And Levi is one of the three people with their cameras on right now, will be the course assistant. And I think you'll probably get better acquainted with him on Friday in the exercise sessions. But I thought maybe the way to start for us would be that I could share my screen and we can go through some basic course information, and then we'll proceed on from there to the lesson for today. I think normally I would say it's great to have your cameras on, but since I have my screen shared almost the entire time, I pretty much never see anybody's face if you do turn your camera on. So there's no need to do that. So yeah, don't fret if you're not wanting to share your face with your camera on today. So here is the web page for the course. I guess all of you should have received an email from me that that gave you some essential links for the course, including this one that would be taking you to the course page. And I'm just going to refresh this because it should be now that lesson 1 is visible. Yep, there it is. So this will be the kind of main hub for all of the content in the course. We can talk a little bit about what that content is in just a moment, but essentially, this is the place where you can go to find information for the course. There's no Moodle page. There's no other place really where information about the course, like the lessons and the exercises, will be. It's all going to be linked from here on the course website. So if you've taken the GeoPython course, this probably looks somewhat familiar. We use the same template for both courses. And so you'll find information organized in the same way on this page as it is in the GeoPython course. So a few basic course details, and then I might ask a few questions to you that you could maybe respond to in chat or something like that. But basically, we're going to meet on Zoom for our normal lessons. And I think that's okay. I mean, it's not ideal, but it'll work for these purposes. It wasn't really worth trying to get a classroom on short notice to try to have our sessions be in person. And frankly, it's a little easier to record things this way, being on Zoom. So that's how we'll meet for the lessons. And those will be on Mondays from 2:15 until 4 o'clock. And that is with one notable exception. That's on the 7th of December. We're going to have a lovely 8 o'clock session. That's because the 6th is Independence Day. And so we have no class on the 6th. So the next possible option was us to be scheduled on 8:15 Tuesday morning. So just be aware that that will be the one exception for our meetings for the class lessons. There are also these exercise support sessions or exercise sessions that you are welcome to come to. They are optional. It's not obligatory that you come there, but I think most students find it useful to come. And they run from 9 o'clock until 1 p.m. on Fridays. And typically, Levi will be the one who is kind of running those, but I will try to pop in when I can. I'll be honest that Friday mornings aren't great for me, so the probability of me being there for any extended amount of time is pretty low, but I'll try to come when I can. This says on Zoom. That is the case for the moment. I'm trying to get a classroom for the exercise sessions because I think it does make a difference for those. Being on Zoom for the lessons is not a big deal, but being on Zoom for the exercises is kind of not that great. So I have requested a classroom. It has not yet been confirmed, and I think there's some kind of like block in the reservation system for the classrooms until tomorrow. But as soon as we know if we have a classroom, there is some space available, but we just don't have confirmation of a reservation yet. But I'll let you know about that so that we can plan to meet in person if possible for the Friday sessions. Those can also be run in a hybrid format. So if there are people who are unable to join in person, it is possible that we could include you online, but in my experience, for things like exercise sessions, it is really nice if you are able to come in person, if you feel comfortable being on campus in person. So just to let you know about that. Here's the information for myself and Levi. You can find our email addresses and things, offices here. Probably the office is not so relevant, but that is where you can find us. And this is one of the ways that you can get in touch is over email. That might be the easiest way to contact us in case you have something urgent come up. Otherwise, there's some links here to the course webpage and the GeoPython course as well, which you might find useful, and some textbooks that are all optional, just listed here so that you have some additional references if you're interested for things that will be relevant to the course. So that is the general course information. And I'm going to actually jump over here for just a second about one practical thing that's related to the GeoPython course. So typically I assume that people have either taken the GeoPython course or have the kind of equivalent introduction to programming previously, preferably in Python, but of course you can learn on the fly in this course as well. But this is normally what I assume people would have learned previously. So you can go here to the GeoPython page if you're interested from the link from our course page. And if you haven't taken the course, you can look through here to see what the contents are and get a sense of what kind of things you would be expected to be familiar with in this course. What I wanted to highlight here is that the GeoPython course also has a bit more detail about things like communicating with Slack. So we did send you a link to join a Slack workspace for the GeoPython course. And then we have a set of channels inside that Slack workspace for the Introduction to Quantitative Geology course. Slack is basically like a channel-based real-time communication, a real-time chat application. And that is probably the best place to ask questions when you have questions in the course. So I think it's better than sending email to post a question in Slack, for instance, because not only is it more likely that I will see it and respond, but it's also more likely that other students will see your questions and then they themselves might be able to find answers to some of the questions just from reading through what's on Slack. So I don't want to spend a great deal of time introducing Slack here because, again, I'm assuming people have taken something like the GeoPython course previously, and you can go to the page in the GeoPython course website to see a little bit of what Slack looks like. Maybe I have it here. So this is some of the kind of interface for Slack. I have a bunch of different Slack organizations, but this is just one for the GeoPython 2021. That's where you'll be invited to join with the link that was sent. And you'll find in there, in the general channel, for example, this set of links where you can go and you can click to join these channels for the Introduction to Quantitative Geology course. We don't make these automatically appear for everyone because this space is used by GeoPython and also another course, Automating GIS Processes, that follows up from the GeoPython course. So you should join Slack with the link that was sent and then go here to the general channel and click on these links that will allow you then to be able to see the channels that we can use week to week. So the general channel in the GeoPython can kind of be a place for anything, but if you have questions that are kind of not specific to a certain lesson for the Intro to QG or Introduction to Quantitative Geology course, you could, for instance, click on the Intro QG general channel, and then you can post something in here like, hi, everybody. And that will pop up, and then people can sort of respond to the things that are asked there. If you have questions about specific weeks in the course, like lesson number 1, exercise number 1, then it's best to put those into the channel for that week. So then we could say here, in Intro to QG week 1, you could ask a question about exercise 1 or lesson 1 here, and it just kind of keeps the discussion a bit more organized that way. In the past, I haven't seen people use Slack a huge amount in this course. It's more heavily used in the GeoPython, but I would very much encourage you to try and use this because it is very convenient to ask questions and answer them in here for both the instructors and I think for the students as well, because rather than an email that just goes and gets one response, everybody can see the questions and the responses. So I think that's about what I want to say for Slack for the moment. And I'll just remind you that on the GeoPython course page, you can go and find more information there if you have never used Slack previously. And I think it's pretty intuitive. So hopefully you'll find that to be the case as well. So that's our general course information. I can also maybe say a couple things about the grading in the course just to get that out of the way right at the beginning here. And it's pretty straightforward. We have 7 exercises in the course. They count for half the grade. The other half is from a little final project report, which we'll introduce closer to the end of the course, but basically builds on the exercises in weeks 6 and 7. And it's like a combination of some written text plus a little bit of Python coding. And I think this link actually does work already, even though you can't see it in the navigation over here. If you go to the grading, you can find the link that gives a description to the previous version of the final paper. So there's a chance that this would be updated because this is from the previous time the course was taught. But you can see here the kind of general view of what you're asked to do and the kind of the task that would be presented to you for the final project. But let's not dwell on that for the moment because it doesn't make a lot of sense to get into that in any detail until we get closer to the end of the course. I guess at this point, maybe I will take a look here at the chat. Are there any questions? I mean, you're free, of course, to unmute and ask if you want, but you could also just type in the chat if you have any questions at this point about the general information about the course. I'm feeling a little bit scatterbrained today, so I hope I haven't just completely forgotten to say something obvious. But yeah, any questions at this point? Okay, so I think if there are no questions, what I would like to do, maybe just out of my own curiosity, is get a sense of who's here that's come from, for instance, the GeoPython course this year, or maybe one of the previous years. So if you want to respond, we can also just test out how everything's working here in Zoom. I would ask that you could go to the participants list, or I think it's in participants list, or maybe it's, sorry, it might be in reactions. And you can put a green check mark, for instance, if you have taken the GeoPython course previously, and maybe a red X if you have not. And this way, just get some rough idea of who has taken the course and who hasn't. Okay, so we have 15 people here, 8 responses so far. Again, you can go to the reactions thing in Zoom to fill in your response if you would like. Looks like 7 of you have had the GeoPython course previously, 3 have not. And I'm aware of at least one of the have-nots. So I guess for the others who have not had GeoPython before, you do have some previous experience with programming or programming in Python even. Looks like I can see one nodding of yes. And okay, so that's good. If you've had some past programming experience. If not, this may be a bit challenging because we do sort of jump in assuming that people have had a bit of exposure to Python in the past. So it's not impossible, but I think, if you haven't had any programming experience before and you've done nothing in Python before, you should maybe let me know in a message on Slack or send me an email so that we can talk about that, because it will be a bit challenging to maybe complete the course if you have no programming experience before. Okay. I have some sense of what you guys have done in the past now. And I don't think there's really too much more to introduce on the course page at the moment, at least not any more general stuff. So then I'll go here to our lesson overview for the first lesson today. And actually, maybe what I can say on the course page before I go there is on the main page of the course, you can see there's some course goals that are laid out here, which is basically to ask you to help you to use Python to explore some common equations that are used in earth sciences. That's one of the main goals in the course. And we'll introduce ways that you can apply Python to study earth processes, for example, and also deal with a little bit of comparing models and data. And that's kind of the overall theme for the course. The schedule that's listed down here gives you maybe a bit more detail about what we're going to do week to week. And this is a little bit modified from previous years when I've taught the course, trying to make things a little more streamlined and maybe a bit more consistent week to week with this revised schedule. So here we are today, where we're going to do a bit of basic geostatistics. And then next week, we'll talk about how to compare predictions to observations. And then after that, we'll go into looking at a few different equations and ways in which they can be applied in the earth sciences. Then week 5 will be talking about building a numerical model, where we're kind of putting together all of these pieces from the previous 4 weeks to try to do something where we can, for instance, simulate or predict some kind of data and compare it to data and have all of our equations included in our prediction, and then these kind of geostatistical equations that we can include to do a comparison. So to make this a little bit more concrete, you could imagine that we might need some kind of equations to calculate things like geochronological ages. And if we calculate those ages, once we have a prediction, we could take an observed data set of geochronological ages and compare those to our predictions. And that'll help us see whether our numerical model is working properly, and is it giving us something meaningful, helping us to understand our data in more detail. So that'll be week 5. And then the last 2 weeks, week 6 and 7, will be basically applying this numerical model that is being developed up until that point to look at some thermochronology data. And so this is something where I don't expect you to know anything about what thermochronology is at this point. We'll get there and explain it in the course so that you can understand what it means. But essentially what we're going to be doing is a little bit of modeling of temperatures in the Earth's crust, and then predicting these thermochronometer ages and comparing our predictions to observed ages from different parts of the world. So that's what we'll do in the last 2 weeks. Again, this won't probably make a great deal of sense until we get a little bit closer. But if you're curious, that's the direction where we're headed. And thermochronology uses bits of all of the previous 5 weeks material in terms of trying to understand the data. So I think it's a nice way to synthesize and to bring together everything that we would have covered up to that point. But yeah, the theme for today is to look at basic geostatistics. So let's jump over to our lesson overview here. So just in terms of how things are set up, each lesson will start with a lesson overview. There'll be some links over here for the different components of the lesson, and then a link to the exercise for that week. So today's lesson, we have to do a little bit of Python stuff. We're going to be introduced to NumPy, which is a Python library that's used for numerical Python calculations, hence the name. And we'll do this in a somewhat interactive way. And then there's a few other lesson pieces here where it's more like information that's presented to you that'll all be relevant for the exercise for this week. So since we don't introduce NumPy in the GeoPython course anymore, I have to give a very brief introduction to NumPy, what it is, why we need to use it, and things like that. And then we'll go through our kind of geostatistics fundamentals in the sections of the lesson that follow after that. And you'll notice that on the overview page, there's something here now that just says a lesson video will be posted after the lesson. So that is the case. That usually takes me maybe an hour or two in the evening to get the lesson video sort of cleaned up and uploaded. And once that's available, I usually put a post in Slack to let you know that the lesson video is there. So if you're unable to attend in any given week, don't worry, you'll have the lesson video available to be able to see what we talked about. Okay, so our lesson on NumPy is where we're going to get started. For some reason, the link doesn't work. I don't know exactly why that is, but it should work from the left side of the page. So yeah, I don't know why the link from the lesson overview doesn't work, but you can go here to the left side and click on a brief introduction to NumPy to see what the lesson is. And I mentioned this is going to be a somewhat interactive lesson, and that is true. And what this means is we're going to be doing some programming in a platform called the Jupyter Notebook. And we're going to be using this CSC Notebooks server, which is where our lesson files will be found and able to be for you to interact with. So for those who have taken the GeoPython course, you'll know already. The webpage we're going to is called notebooks.csc.fi. I have it open here in the tab. I could just copy paste the link there. If you've already joined in the GeoPython course, you should find that when you sign in, you can use your Hakka authentication, which is allow you to use your university username and password to sign in. And when you sign in, you'll see that there are several environments here, including this Intro QG 2021 environment now, and that's what you should be using for today's lesson. If you have not taken the GeoPython course, you probably will not see this stuff. And the reason is that you'll need to go to groups and to join a group to be able to see these environments. So once you sign in, actually we can go here to the GeoPython course page for just a second, because I think we introduced this here in the course environment. Again, that's a good place to go and have a look. So here in our cloud computing environment, you go to this link to log in, notebooks.csc.fi. You can then go to the account tab, and you're going to join the group GeoPython using this join code. So I'll again put that in chat for you. And this basically will allow you, once you use that join code, to be able to see these environments. And what these are, we'll see in just a moment. If you're totally unfamiliar with what a Jupyter Notebook is, you'll see them in just a second. But essentially, this is kind of a pre-configured environment that has all of the files that we need for the course available. And this CSC Notebooks platform is basically the server where our notebook will be hosted. And so can I ask again, if you don't mind, that you go to the reactions and put a green check mark when you've been able to sign in, and also to launch a new instance of this Intro QG 2021. So just put a green check mark when that's the case. And if you're having problems, please maybe put a red X, and then that way we can know that that you need some help. So just as you're getting signed in and getting connected, you don't, strictly speaking, you don't need to do this to follow the lesson today. You can just sit and watch, but it will probably be better in a sense to have this notebooks system open so that you can do some of the interactive parts of the lesson. And what I tend to do is kind of follow what's on the course page in terms of the lesson, but sometimes I start adding in unexpected things. They're answering questions with some additional code, and it's nice maybe to follow along so you can test things out yourself. Once you click launch new, you'll see that it takes maybe 30 seconds or so for the instance to spin up and be ready to be used. You'll get a check mark when the instance is ready. And then you'll also be able to then click on this link to open in browser. And you click that and it'll prompt you at that point about whether you want to copy some password, and you just want to click the copy and continue button. And then when you come to the next page that comes up, you can paste in the password. And after that, it should take you to a page that looks like this. So again, please put the green check marks if you're able to get to this point. Maybe I'll just do it like that. So if you're already here in the Jupyter lab, you can put the green check mark. If you're having problems, you can put a red X. And I'll continue in just a moment once it looks like we have a few more green check marks. Okay, we are up to 10 green check marks now. That's pretty good. Still a few missing. 11 now. Okay. So again, please say something in chat or put a red X if you're having problems, but I'll continue at this point because it looks like everybody's been able to get here. So this is the Jupyter Lab, which is one of the places where these notebook files can be hosted. Inside here, you'll see you should have an intro QG directory that should have appeared automatically. And if you double click on that, you'll find in there that there's a notebooks and an exercises folder. We're going to go to the notebooks folder for right now. I double click on that. You'll then see there's an L1 for lesson 1. And if, again, you double click on there, you'll find in here a number of these notebook files. The first one of which is called numpy.ipynb. So that's what we're going to double click on to open that up. And yeah, so again, I'm assuming you know a little bit of Python already. You might not know this Jupyter Notebooks platform from your previous Python programming experience, but I think you'll find relatively quickly that you'll pick it up. It's a little bit weird at first to use compared to writing regular Python, but the whole point here is that we can have a single document where we mix together code and documentation in the same place. So our lesson file itself, and the file that's actually used to produce the lesson on the course page, is a Jupyter notebook, and it contains code cells and then what are called markdown cells, which is where we can put in our richly formatted text, including headings and links and tables and all kinds of stuff like that. For our lesson for today, where we're going to get started, it's about NumPy. And well, you can find a tiny bit of text here about what NumPy can do at the top. Essentially for us, the biggest thing we're going to use NumPy for is for generating arrays of values. So if we were going to calculate something like the temperature in the crust from 0 down to 50 kilometers depth, we can create with NumPy arrays of values so that we would have a depth, position, and maybe every half a kilometer from 0 to 50 kilometers in the Earth's crust, where we could then calculate temperature after that. So just like any other Python library or module, we need to start by importing. So you can type in here, for instance, import NumPy, and the tradition is to import it as NP. So again, if you haven't done this previously, this is just a way to sort of rename the library when we import it. And to run code in a Jupyter notebook, you can either press Shift Enter, or you can click the play button up at the top of the screen. I'm kind of anti-mouse, so it's Shift Enter for me. That will then produce no output, but it will load in the NumPy library so that the functions that are part of NumPy are now available to us. And that will allow us to do things like, for instance, calculate what the sine function would be of a variable x that has 10 points or 10 values between 0 and 2 pi. So we can start by creating an array of values called x, like this. So we just say x equals, and then we're going to use a function in NumPy called linspace, np.linspace. And the function here is going to expect 3 values. The first one is the starting value. So we said here we want to go from 0 to 2 pi. We're going to start then at 0. We're going to go up to 2 times np.pi. So NumPy has in its library a defined value of pi that we can take advantage of. So we have 2 times np.pi. And then I said to do this in 10 points. So then we can just add 10 there to say that we want 10 steps to go from 0 to 2 pi. If you run that cell, it doesn't, again, produce any output, but if we then print out the values of x, what you should see is something that looks like this. So you can see here our values going from 0, 0.69, 1.39, etc., up to, that looks pretty close to 2 pi. So the linspace function in NumPy allows us to create an array of values starting at one value and ending at another one. So this will go all the way up to 2 pi. And then here we can just specify the number of steps we want. So if we increased it to 100 steps, we run this, and then you print it out, and now you have 100 values going from 0 to 2 pi. I'm going to back it off back just to 10 for the moment, but you can see it's very easy to change the number of points where you're going to do your calculation using this approach. And again, this can be used for all different kinds of things where oftentimes with some kind of numerical model, you have some spatial or time variable that you want to define to go from some starting time to an ending time, or from some position to another. And the linspace function is one of the easiest ways to do that. You can see the syntax here looks like np.linspace, start, stop, and then the number of increments, which we've kind of already covered. So I hope that that seems fairly clear at this point how this function is working. So I mentioned we were going to calculate, though, what the sine of pi was. And so let's do that with another variable here. So we could say y equals np.sine. So as you might expect, NumPy has built-in trigonometry functions as well. So there's sines, cosines, tangents, etc. And if we just do np.sine of x, that will calculate the sine value at each one of those positions of x. And then if we print that out, again, what you see here is now the sine of x starting at 0. That should hopefully make sense because the sine function starts at 0 at x equals 0. And it goes up to some maximum value here that's going to get close to 1. Then it comes back down and eventually ends up at 2 pi, very close to 0 once again. You'll see it's not exactly 0, but it's pretty close. Minus 2.44 times 10 to the minus 16 is pretty close to 0. Again, the nice thing about this is if we change the number of points where we want to calculate x like we did before, I can just go back up. The order in which I run the cells doesn't really matter. So I'll just go back up here, make x equal to np linspace now with 100 points, run my calculation of what the sine of x should be again here. And if I print it out, again, now I have 100 points where I have calculated the sine function. So just to make this kind of a little bit more clear, well, I don't know, maybe this won't make it more clear, but Just to show, for those who've done the GeoPython course, you might remember that we used matplotlib a little bit. And we always called it PLT. So let's just make a quick plot of this sine function just so you can see what it looks like. And of course, to start with that, we need to import matplotlib first, and then we should be able to do plt.plot x, comma, y. We'll just keep it simple here, not going to add any axis labels or anything like that. But matplotlib will allow us to generate a simple plot of our data. It takes a second to import, and then what you should see is that you have now on y, this should be your sine function. X is the range over which our x value is defined, going from 0 to 2 pi. And then you get one full sine curve from 0 up to 1, back to -1, and then back to 0 here with what we've calculated so far. And currently, of course, this is based on having 100 values because we defined 100 values for x here. If we decreased it back to 10 and did the same plot again, you see you get a kind of a little bit more chunky looking sine plot because you have fewer points at which you're calculating the values, and you get this straight lines connecting between the points. So that is the linspace function. I just wanted to show that you can make the plot very easily to see what it looks like. And this is one of the reasons why you might like to use something like NumPy, is to do things like plot different function values across some range of numbers. We can also do things a little bit differently. So if we wanted to, we can use a fixed increment between values as well. So we could say with a value here for x2, so this is just our second pass at creating an array of x values, we could use np.arange. Again, this will allow us now to specify a constant spacing between the points in the x2 array. So we can have it that we start at 0 again. We can go to 2 times np.pi again for our maximum value. And in this case, we can use an increment of 0.5 between the points. So then if we print out x2 here, I guess I should run this cell first to define x2. Print it out. Now we see our x2 array goes 0, 0.5, 1, 1.5, 2, blah, 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 up to 6. Now, what's important here is that just like the range function in Python, the arange function is something you have to be a little bit careful with because it works differently than the np.linspace function does. Let's imagine we wanted to go from 0 to 5.0 in increments of 0.5. You might expect this to go 0, 0.5, 1, 1.5, blah, 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 up to 5. But if we run it, what you'll see is it goes up to 4.5 because it doesn't include this last value if that last value happens to be an increment of the step size that you're looking at. And this is actually just like the range function. If we use the range function in Python and we say, give us a range function, actually with the same input values that we have right here. I'll just copy this and just demonstrate, because just copy that. So instead of doing np.arange, we just do range. And okay, it doesn't like that it's floating point numbers. It wants to do whole numbers, whatever. But here for range, if we say 0 to 5, as you might remember from the GeoPython course, when you run this, of course, it just tells me that that's the range. But if I also printing it doesn't seem to work. All right, fine, let's do it like this. So if we say for value in range 0, 5, print value, we get 0, 1, 2, 3, 4. We don't get that last value in the range function, which again, this is just something that's quirky a little bit about Python. The idea with it is that when you give the range function a single number, it will give you back that many increments or that many steps. So if you do range of 5, and you print it out, you get 0, 1, 2, 3, 4, which is together 5 numbers, but of course it starts at 0, so it doesn't include the number 5 as the last value there. Same thing for the np.arange function. It doesn't seem to mind if you give it a sort of decimal value here for the step, whereas range seems to want integers. But you see the point that you have to be a little bit careful with arange, because it's great to be able to specify the step size. It's not great to not have this last value included. And there are tricks for how to handle this. I mean, you could make this be 5.01. And when you run that, you'll see that now you have the value of 5.0 in the output for the arange function. So as long as this is not an exact increment of the step size, then you'll see that last value will be printed out. As long as it's bigger, of course, if it was 4.99, then yes, we won't see 5.0, because of course 5.0 is less than, or is greater than rather, 4.99. So naturally that won't be printed out. But this syntax looks very similar between arange and linspace. And it's just a question of, do you want to specify a constant step size, or do you want to specify the number of steps to take? Often the case is that the number of steps to take is more important. So most of the time I would suggest that you use the linspace function. So not arange, but you should use linspace, although they can do basically the same thing. All right, one other thing with NumPy that can be worth exploring, and that is generating random numbers. So for this, there is a random number generator, or several kind of pseudo-random number generators in NumPy. So here we could make a variable called rand equal to np.random.rand. And then you specify the number of values you want, for instance. So this would give us 10 random numbers between 0 and up to but not including 1.0. So if I run that and then print out rand, what you should see is you get some list of random numbers between 0 and 1. This will give us by default floating point numbers that come back, but there are also random integer functions. There are other things that are available to you if you want to generate random numbers using NumPy. But these 3 things, arange, linspace, and the random number generation, are the 3 things from NumPy that we will need that you would not have seen yet. Maybe you've seen the random number generation in GeoPython, but otherwise I don't think we saw linspace or arange. And we won't go into great detail here with what we're going to do in NumPy, because we try, like the GeoPython course, to use pandas as much as we can. But of course, we do have things that we can't do in pandas, like making arrays of values. But if you're curious, there's a link here to the NumPy website, and you can go there and see more information, for instance, about the random sampling from numpy.random. This is actually not the link I was thinking it was. So I was thinking more like NumPy would take us to the NumPy homepage. And if you're interested, you can find more about what NumPy does, how to use it, and you can also do things like follow some of these NumPy tutorials that will introduce you to how NumPy is working. And as mentioned in the GeoPython course previously, NumPy is sort of under the hood in pandas, and quite a few of the other computational packages that are used in Python are using NumPy in the background. So it's a pretty fundamental piece of writing Python code. All right, any questions at this point? Again, very quick introduction to NumPy, just because you'll need it in the lesson for this week. Okay, so I think we can get away with a 5-minute break. So before we continue with the next part of the lesson, why don't we take 5 minutes And we'll come back and continue with a little bit of basic terms for geostatistics. I'm going to go get some tea, and I'll see you back here at 3:06, so 5 minutes from now.